All right, so for this video, we are learning how to write absolute value functions as piecewise functions. So a piecewise function is two different equations graphed on the same sheet of paper at the same time, and you draw one for one portion of the graph and you draw the other one for the other portion. So you have like the left side of one and the right side of the other. So what we're going to look at is if I can take an absolute value function and split it apart and write it as a piecewise function. And it will make more sense once we draw a picture. So we're going to go ahead and draw just a typical absolute value equation. We're going to say y equals the absolute value of x. And if you guys remember, that's just a perfect V-shaped graph. So it starts at 0, 0, and then it goes over 1, up 1, over 1, up 1, over 1, up 1, and over 1, up 1, over 1, up 1, over 1, up 1. And so the way that we write the piecewise function is first we find the vertex, because that is where it switches directions. It starts where it's going down and then it switches directions and it goes up. So I'm going to say the vertex is at 0, 0. And this x value of 0 is where it switches directions. And so I'm going to say that the left side of the graph is actually a straight line, and it has a slope of -1. It goes down 1, right 1, down 1, right 1, down 1, right 1. And it goes through the point 0, 0. So I'm going to say that I have the slope of -1 over 1 x plus 0. That is the left side of the graph. The right side of the graph, I'm going to say, has a slope of up 1, right 1, up 1, right 1, up 1, right 1, and a y-intercept of 0. So we have the left side of the graph and the right side of the graph. And so this is how I'm going to write the graph as a piecewise function. I'm writing it using two pieces. So I'm going to say the left side of the graph, we're going to use the negative version of a linear function if the x value is less than 0. And we're going to use the right side if x is greater than 0. Because for the left side, I want that negative slope. For the right side, I want that positive slope. And so this is how I could rewrite a piecewise graph, or sorry, an absolute value graph, if I didn't want to use an absolute value symbol. I could say, oh, it's like a negative line connected to a positive line, and then that would draw the graph. Now, right here, for what I have drawn, it's kind of like I'm saying that there's a hole right here in the middle of the graph, because I'm never telling you that the x value can actually equal 0. It's kind of like I skipped over that. So what we have to do, because we don't want to have a hole right here, what we have to do is we have to decide that one of these is going to equal 0, and it doesn't matter which one, and so I'm just going to put this one to equal 0. I'll always do it for the top one. All right, so don't be worried if that was kind of confusing. After we do some examples, you can at least learn the pattern. Even if you don't understand where it came from, you can learn the pattern and then it will make more sense. So if we clean this up a little bit, we would just say this is negative x if x is less than or equal to 0, and positive x if x is greater than 0. Okay, so we're going to go through some examples. We're going to take y equals x minus 5 plus 1, and we're going to go ahead and write it as a piecewise function. So I'm going to start by finding the vertex of the piecewise function, and if you guys recall, the vertex is always the opposite of this number, and then exactly what that number says. So it's +5, +1. And so the value of the x that would make this line switch directions would be an x value of 5. So it's going to go down, and then it's going to hit the 5, and then it's going to switch directions. And so when we write this as a piecewise function, we would say I'm going to use the negative version of the absolute value if x is less than or equal to 5, and I'm going to use the positive version if x is greater than 5. And then I'm going to go ahead and simplify that. So I'll do my work off to the side here. I have negative of x minus 5 plus 1. This negative sign gets distributed. So I have negative x plus 5 plus 1. And that gives me negative x plus 6. And then for the other one, I just have x minus 5 plus 1. There's nothing to distribute, so I'll just go ahead and rewrite it. And then when I combine my like terms, I get x minus 4. So the piecewise function is negative x plus 6 if x is less than or equal to 5, and x minus 4 if x is greater than 5. And this is my answer. So I took the absolute value equation and I rewrote it as a piecewise function where I have a straight line connected to another straight line, making that perfect V shape. All right, here's another one. Okay, so first thing, I'm going to find the vertex. It's the opposite of this number, so it's -3, -4. And then I'm going to go ahead and start writing it. I have the negative version. So you can see that when I rewrite the problem, when I do the negative version, I put a negative in the very front, and then I just exchange those absolute value signs for parentheses. So I have the negative version if x is less than or equal to -3, and I have the positive version if x is greater than -3. And then I can go ahead and do my work off to the side again. So -2 times x plus 3 minus 4. I'm going to distribute that -2. Yep. And then I can go ahead and combine like terms. And then I'll do the other piece. So I've got 2x plus 6 minus 4. And so those are my two straight lines. So I've got -2x minus 10 if x is less than or equal to -3, or positive 2x plus 2 if x is greater than -3. All right, and I'll do one last example just to make sure that we've got it. Just leave it like that. Okay, so the vertex of this one is -1, 0. And so we've got y equals the negative version if x is less than or equal to -1, and the positive version if x is greater than -1. And I'll go ahead, I don't really need to show my work off to the side because I can kind of do this right here. So that's negative 7x minus 7 if x is less than or equal to negative 1, and then positive 7x plus 7 if x is greater than negative 1. So the key to being able to take an absolute value function and write it as a piecewise is to know what the x-coordinate of the vertex is, because that number goes here. And then we do the negative version if x is less than or equal to that number. We do the positive version if x is greater than or equal to that number. And so what this is doing right here is you're saying use the negative line if you're on the left side, use the positive line if you're on the right side. We stop it right in the middle because that's where it switches places. So that's how we know we get the perfect V when we draw the graph.